In the far polar north, on the island of Spitsbergen, in Norway's Svalbard archipelago, a team of scientists from the Earth Observatory of Singapore are about to embark on a research field trip to combat climate change 10,000 kilometers away. The reason why? Sea level rise.
That was the most amazing flight I've ever had in my life.
The scientific team from Singapore are guests of the Norwegian Embassy and are here to establish collaborative research programs around polar sea ice melt and its future impacts on sea level rise across Southeast Asia by 2100.
It is quite simply amazing to be here in Svalbard in the Arctic. This environment blows my mind. The Arctic is the region on the planet where climate change is happening faster than anywhere else on the planet. If we look at global mean temperatures, in the last 100 years, they've gone up around 1 degree C. But here in the Arctic, they've gone up 3 degrees C. And the implications are profound. If we don't do anything about climate change, this landscape will be totally different. It's warming up at a rate that has not been seen for 12,000 years. This environment will be ice-free by the end of this century if we don't do anything about climate change.
Professor Horton is joined by two of his young researchers, Trina and Druba, who will be undertaking research projects with Bergen University.
We're driving up to the KSAT satellite service, and this is part of an international collaboration between the Singaporean and the Norwegian space agencies. We're interested in working with them to monitor climate change. So to monitor how the Arctic is changing, but also the tropical regions in and around Singapore.
Planning for this collaboration started several years back when the Norwegian ambassador to Singapore visited the Earth Observatory to discuss future research collaborations.
Scientifically, there are lots of ways that we can cross-pollinate to make sure that we provide the best possible data for our individual governments on climate change.
I'm really hopeful that the collaboration that you are now starting with NORS in Norway, with our universities, that will truly deliver these complementary knowledge and benefits that comes with working together.
After many years of planning, Professor Horton and his team visit KSAT, the leading provider of Earth and ground observation services in Svalbard. Here, data from polar orbiting satellites monitoring climate change is downloaded and shared globally in real time with scientific hubs like the Earth Observatory of Singapore. When the team arrive at KSAT, the outside temperature is minus 10 degrees Celsius, but inside, it's a cozy 20 degrees. KSAT manager Jorge briefs the group on the center's operations.
Okay, thank you ever so much for inviting the Earth Observatory of Singapore to KSAT.
It's just my pleasure.
Yeah, this is one of the most stunning research centres I have ever seen.
Guys, it's beautiful. Look at the view.
Yeah. So KSAT, I mean, how long has it been operational for?
Well, KSAT started up here on Svalbard in 1997, and that was actually one antenna, the antenna behind us here.
Yeah.
And sort of been growing a lot, and today, 2022, we have 140 antenna systems.
140?
So that's quite something.
What a growth rate.
Yeah, it is. So it's kind of amazing also because you receive real-time data from a spacecraft. It is downloaded here on Svalbard, And in real time you can have it in, say, Singapore, or you can have it in Germany, or in North America. You have the data.
Yeah, that's just such a powerful tool. You're making such a difference to monitoring planet Earth. I mean, I think that's phenomenal.
If you're like this one part of this huge machinery, that's sort of...
Yeah, but you're not one part. You're a key thing. I mean, that's just the thing that blows me away. I mean, there are so many, billion people on the planet that rely on understanding how the Earth works. And then there are a variety of analysts who then look at that data, but it all has to come from somewhere. And if it's coming from KSAT, and your team are such importance.
KSAT gathers data on atmosphere, sea ice melt, ocean flow, and changes in the Greenland Glacier. This is one of the key centers where the big picture on climate change is being tracked.
You've lived in this beautiful environment for several years.
Yeah.
I mean, do you yourself, can you tell that the Arctic's changing?
There's one definite answer, and that's yes. And it's quite troubling.
You're in an environment where, the sea ice is being lost at several % per year. You've got the Greenland ice sheet melting. You've got your alpine glaciers disappearing. You've got the changes in the ecosystem happening. You understand what we're doing to the atmosphere and how it starts to change your life. In Singapore, we've not yet experienced the changes in climate extremes yet. It's really important that we can work together. The collaboration between KSAT and the Earth Observatory of Singapore is part of that key aspect that if we're going to solve global climate change, we need to work as a global community.
Oh yeah.
Professor Horton and his team at the Earth Observatory of Singapore are keen to understand the significance of these changes in the Arctic and the impact they'll have on communities and businesses across Asia. Data modeling is vital to help governments build adaptive strategies for future generations.
In Southeast Asia, because of the very high population density, it's estimated that 600 million people will be inundated by rising seas by the end of this century. Sea level rise is a complex problem. Sea level rise will be different here in Singapore than it is in Jakarta, than it is in Manila. That is because there are a variety of global, regional and local processes that vary in time and in space. Globally, there are two main drivers. The first driver is the temperature of the ocean. If the temperature of the ocean increases, it occupies a greater volume and sea level goes up. The second global driver is the melting of ice sheets. Ice sheets 10,000 miles away from Singapore are melting. That land-based ice is going into our oceans and sea level goes up.
Going into the future, the impact of the rapid melting of sea ice and glaciers in the Arctic regions on sea level rise is also having an effect on the gravitational pull of the Earth-ocean relationship. But just how does this affect regional sea level rise in Southeast Asia?
Most people are surprised to learn that just as the surface of the Earth is not flat, the surface of the ocean is not flat, and that the amount of sea level rise will vary from place to place. One of the sea level rise hotspots, unfortunately, is Southeast Asia. And this is because of the gravity of the Earth. Greenland and Antarctica are so large that they exert a significant gravitational pull on the water, which means that all the water on our planet is drawn towards our poles. When that ice sheet melts, however, the force of this pull to the pole weakens. This means that more water is drawn to the equator. So when an ice sheet melts, Countries in Southeast Asia, such as Singapore, that sit along the equator will get much more water than other places. And at the Earth Observatory of Singapore, we calculated that if the Greenland ice sheet contributes 1 metre of sea level rise, Singapore would receive 1.3 metres, or 30% more.
Data collected around the world from satellites monitoring Earth systems at stations like KSAT in Norway are helping scientists model how fast and how high sea level will rise if greenhouse gas emissions are not radically reduced by 2100.
Sea level rise is an existential threat to Singapore and other low-lying nations. But let's put some facts and figures to this. So the increase in atmospheric temperatures in the 20th century as a result of greenhouse gas emissions has risen global sea level by just 20 centimetres. The emissions of the 21st century suggests that sea level rise in the next 30 years out to 2050 will raise global sea levels by a further 30 centimetres to half a metre. By the end of this century, if we don't mitigate against greenhouse gases, sea level will rise approximately 1 metre.
Scientists are exceedingly worried about the melt of ice sheets in both Greenland and Antarctic. Research hubs like KSAT are tracking and monitoring ocean dynamics globally.
The Antarctic ice sheet is the existential threat to island nations like Singapore. This is because it has a colossal amount of water within it. The ice sheet contains 65 metres of sea level rise within it. If you melt a small percentage of it, you have a dramatic impact. And the scientific community have come out with estimations of what sea level will be by 2100 if we destabilise that ice sheet. And for Singapore, the value for 2100 is 1.7 metres. But this process will only accelerate. And by 2150, the ice sheet is like a runaway train, and the amount of sea level rise that Singapore will receive will be a colossal 5 metres of sea level rise. When this happens, it's a reality to Singapore and every other island nation on this planet.
Beneath the cold, dark depths of the Arctic Ocean sit another alarming reality. Vast reserves of methane, a gas 30 times hotter than CO2, and it's starting to escape. Scientists are undertaking expeditions to better understand if pressure from the shifting ice sheets could trigger instability in the sea floor, releasing stored methane into the atmosphere. The research vessel is used by the Arctic University of Norway across the polar region for extensive deep ocean surveys. It's equipped with sophisticated scanners, capable of making environmental measurements to a depth of 1,000 meters.
And what we do here, we would like to understand better the dynamics of methane. So how much methane is emitted in the Arctic? Is this decreasing, increasing?
So how do you do that? I mean, so you're going on this boat, she's going out on a voyage around the Arctic Circle, and you've got a variety of sites that you're going to stop at?
Yeah, exactly. We have identified 4 areas actually that we would like to investigate in deep. And we are going to use mostly the instrument on the vessel to guide us to identify these locations, and then we have an ROV on board, a remotely operated vehicle. The ROV will give us the possibility to take the samples that are needed for our research. We also have sensors that will give us the possibility to measure the temperature at the bottom of the ocean,
Right,
but
okay.
mostly methane,
Yeah.
which is this gas in which we are interested in actually.
So why are we so concerned about methane being released from the Arctic?
Well, because methane is a greenhouse gas, and it is important to understand how much is emitted. And we know, of course, that most of the methane is consumed already in the sediment by microorganisms. Most of it is consumed in the water column, but maybe some methane escapes into the atmosphere.
You're interested in the sort of feedback effects of an increase or decrease in the amount of methane?
Absolutely.
While scientists are working to identify how fast methane, locked away under the Arctic Ocean, is escaping, the vast tundra plains across the polar regions, which carry huge reserves of permafrost, are ringing alarm bells.
This ground is warming, and as it warms, there is thawing of permafrost. And we see it in Svalbard, we see it in Siberia, we see it in Canada. As the permafrost thaws, there are all sorts of things happening with collapsing ground, houses collapsing. There are all sorts of direct physical effects. But there is also then the question of the methane hydrates or the clathrates that exist in the ground. This has been a very big question mark in our understanding of the system. Can there be a very rapid release of methane from the permafrost? We have looked at it in many places, but we don't know. It remains one of the largest long-term uncertainties in the system. There is probably more methane locked up as methane hydrates in the permafrost of the Arctic than the entire fossil fuel reserves on the planet.
Migration of the Arctic waters here in the polar region drive the largest ocean current in the world. But if this ocean current slows down, it could have catastrophic impacts on the global climate system.
So we're located here in Svalbard, a unique location that controls the circulation of the whole of our planet. Here around Svalbard, the cold, most dense water on our planet sinks to the bottom of the ocean floor in the Arctic, is transported along the North Atlantic to the South Atlantic and upwells around Antarctica. It then goes on a circumplanetary current, upwelling again in the Indian Ocean, going around South Africa, ending back up in the Gulf of Mexico. This is known as the thermohaline circulation. Warm water in the Gulf of Mexico migrates around the North Atlantic coastline, ending up here in the Arctic Circle in Svalbard as very dense and very, very cold, and it sinks. Now this transports heat around the planet. It transports the warm water of the tropics out to the Arctic. It keeps the environment for every single person on the planet habitable. If the thermohaline slows down, then we have catastrophic climate changes. And because of climate change, we are worried that the thermohaline is starting to slow down. Because as I've said, the thermohaline is because the water is dense. It's dense because it has lots of salt in it. But if you melt the Greenland ice sheet, fresh water comes into the thermohaline current, the salinity, the amount of salt decreases, and the thermohaline slows down. If the thermohaline was to shut down, it would cause temperature changes in excess of 5 or 10 degrees C to occur in a timescale of less than 50 years. This has happened in the geological past. but human civilization has never, ever experienced it. It's one of the tipping points, the thresholds of climate change, that what happens here in the Arctic could influence every single person on planet Earth.
As scientific research vessels gather to investigate the changes happening in the Arctic Ocean, a group of international researchers, scientists, policymakers, and Indigenous people of the Arctic are arriving in Tromsø to attend the Arctic Frontiers Conference. Ben and his team have made their way south to establish further collaborative partnerships.
So those learnings that we got last year were really valuable in this experience.
And what a setting it is, Tromsø.
Arctic Frontiers is one of the largest global arrangements about the Arctic and in the Arctic. Each year, Arctic Frontiers takes place here in Tromsø and gathers delegates from well over 30 countries to discuss pressing Arctic issues. And the science part of the conference is crucial, because while gathering the scientists, we are actually able to present the newest research within the different scientific fields.
While scientists gather to share data being recorded here in the Arctic, the Sami people of Norway are sharing their lived stories about how fast the climate is changing and the big challenges facing reindeer herding in the Arctic, which has been part of their culture for hundreds of years.
There have been so big change on these last years, and same as my dad actually, he also have a lot of stories because there is a big change in the nature, and of course I'm very worried and I feel very sad that my generation might not have the chance to experience different things in the nature, especially with the reindeer herding then. Now in wintertime we have to give reindeer some extra food because in the winter time, one day comes a lot of rain on the land, and the other day is getting 30- degree. The pasture is getting very icy, and the reindeer can't get or find any food. When my grandfather was young, he said that they have more stable winters. So when it gets stable, they didn't have these problems as we have today.
Arctic Frontiers has long-standing excellent collaboration with our partners in Singapore, and we are really excited to have strong Singaporean delegation with us this year, with Professor Ben Horton from the Earth Observatory in Singapore and Special Envoy Sam Tan from the Singaporean Minister for Foreign Affairs. Their interest in the Arctic and our interest in collaborating with our partners in Singapore is really a testimony of the character of the Arctic. It's not just about the region, because the impacts of what we see going on in here are global, and therefore we need a global effort as we want to carve a pathway forward. "10,000 kilometers away from Singapore, two young scientists, Trina and Druba from Professor Horton's group, are here in Tromsø to collaborate with the scientists on longitudinal studies on sea ice melt in the Arctic. And Norway is one big laboratory for this Arctic experience.
There are many factors affecting sea level change in different parts of the world, and particularly for where I come from, Singapore, it lies very near the equator. It's on the lower latitude, it's very far away from the polar regions. But that's the thing, even though we're really, really far away from the polar regions, the ice melt here in the Arctic would really, really affect Singapore's sea level in time to come.
Working to solve climate change requires local and global engagement. Professor Horton is keen to lead the way and provide opportunities for emerging scientists from Southeast Asia to be part of the changing Arctic with institutes like the Arctic University of Norway.
Is there anything unique? Are you trying to be interdisciplinary regarding changing the Arctic, looking at different aspects, not just the changing atmosphere or the changing sea ice?
Definitely. I think it's crucial actually to be interdisciplinary to understand what's going on and to solve the problems and to understand what's going to happen in the future here in the Arctic.
Well, I would really like the Earth Observatory of Singapore to be part of the changing Arctic and to interact with UIT. I think that there are many similarities in terms of the expertise, but also there are many differences. And I think if we're going to solve climate change, you need to have the partnerships of all scientists around the globe. And I think Singapore and Norway could come together in rather a unique partnership.
You're very much welcome, and I really hope that we can establish collaboration in terms of exchange of students, and maybe also to make some research projects together.
One of the biggest challenges is the role of ocean dynamics. We do not understand how the Arctic Ocean and the ocean circulations over this region can change the climate and sea level over Southeast Asia. So in my research here in Bergen, I will work to better understand how the ocean circulations in this region can have impact on sea level rise over Southeast Asia.
So studying changes in the Arctic is important for every single person in Singapore, every single person in Southeast Asia, indeed every single person on the planet, because changes here in the Arctic influence how ocean heat is transported from the tropics to the high latitudes. Understanding the Arctic enables us to think about planetary heat, how much incoming solar radiation is reflected back out into space. Understanding the Arctic tells us how high sea level will be, because the glaciers, the ice caps, the Greenland ice sheet is melting, contributing mass to our oceans, and sea levels are going up. So if we want to understand climate change, we need to work together. Scientists from Norway and Singapore and elsewhere. If we work together, we can provide the solutions for a healthy planet.
The future is uncertain. We are, as humankind, we are responsible for the directions we are taking, and we need to be humble, we need to be prudent, because the larger the perturbation, the larger the change we create, the less we know about where we will end up. And we're taking risks with each other's lives, with our own future.